Okay, here's part five of our exhaust after treatment little series here. A couple things I skipped in that last one. Just remember that there's a lot of a lot of theories out there that's not true. Yeah. Chicken urine does have urea in it, but that's not where we get it. We don't have a bunch of chickens walking around with catheters on them collecting their pee to put in this tank. I've had drivers say that other drivers have told them that if you're low, you can pee in it and it won't know the difference. It will. That's not what it's looking for. None of that's true. You have to have the right DEF fluid in it, and it will know if it doesn't have that or if that DEF fluid's gone bad. There's a refractometer to check DEF fluid. It's just like a coolant refractometer, but it's made for DEF fluid. You can check the quality of it to make sure it hasn't been watered down. It'll just tell you the mixture of it's right, though it won't really tell you the quality. The quality thing will be determined by the ECM, and we'll get to that here in a minute. So it's actually the DEF fluid we use. The urea is made as a byproduct, I believe, of refining natural gas to do some other things, and that's where we get our urea mostly from, is from natural gas, once again, the petroleum industry. So let's see, anything else about the DEF fluid? That pretty much covers that. Talked about it freezing. Okay, so this ammonia goes into our exhaust system, and what it does to NOx, the ammonia has no effect on particulate matter. The DEF fluid has no effect on particulate matter. It doesn't affect fuel economy like our other emissions devices we've already talked about. The DPF affects fuel mileage, the EGR affects it. DEF fluid does not affect fuel mileage. It is just made to undo NOx. So our ammonia goes into NOx, which is NOx, and it has a reaction with it, and it separates. Now remember, ammonia, let me back to this. Ammonia, the symbol for it is big, or capital N, capital H, and a little 3, so NH3 is ammonia, the scientific term for it. So this ammonia that's created once the DEF fluid sprayed in and mixes with some of the chemicals in the exhaust, it goes in and removes O2 from NOx. So when you remove the O2 from NOx, where it was oxidized because you added oxygen, oxidized oxygen, so you burned oxygen and it formed with NOx with the nitrogen. That's how it gets NOx. Basically, it just splits those back apart. So now we have O2 and nitrogen in our selective catalyst reduction device here, our SCR. So it just undoes what you did in the cylinder. So now we are back to nitrogen, which is normal to the air and normal to the environment because it was already there, and O2. But then the O2 mixes with the hydrocarbons, a little bit of hydrocarbons that still have made it through the DPF and all that. And that's why what comes out of the exhaust on this SCR equipped engine, when everything's working right, is nitrogen and water vapor. If you put your hand up to the exhaust, now don't touch the exhaust, but just a little bit away from it with this engine running, or with anything with SCR. First of all, you won't be able to smell it, but you'll feel water forming on your hand, and it's just a water vapor. And you still have some carbon monoxide, which is bad. That's why you need the exhaust system on it. It's for the carbon monoxide. You're still producing some carbon dioxide because you burnt this carbon-based fuel. But the two bad things, the particulate matter, soot, whatever you want to call it, and the NOx has been taken care of by these 3 canisters right here, along with the EGR and whatnot. So the way the SCR knows if it's doing its job, it's got temperature sensors on it. So we got 2 more temperature sensors. Temperature sensor 4 is down on the inlet. Temperature sensor 5 is right here near the outlet of the SCR. So we still got a temperature sensor there. That's for the computer to know how all this is working and be able to troubleshoot problems and know what the SCR temperature is, because then it knows what kind of reaction you should be having. If the SCR is at the right temperature, inlet and outlet, then it has what's called NOx sensors. So there's a NOx sensor. It's hard to see up under this, but up under this cover here in this SCR, more toward the inlet is a NOx sensor. So that's determining the NOx levels in the exhaust, or the oxides of nitrogen level in the exhaust at the inlet. And then it's got one here at the outlet. These look really similar and work really similar to an O2 sensor on a gas engine. So O2 sensors have been around a long time. They're just measuring the amount of oxygen. This is a NOx sensor. It's measuring the amount of nitrogen, or oxides of nitrogen in the system. So the way it knows that this diesel exhaust fluid is any good, the ECM controls the flow. If it doesn't need any DEF fluid flow, nothing's going to be flowing out of that doser. It measures these NOx sensors, gives it a feedback to the ECM, and then it controls how much flow we have to reduce NOx. So if it's got its little algorithm and knows the temperature in there and the levels and all this, and it says, okay, this amount of DEF fluid should reduce that, and it doesn't see that happen, then it says something's wrong. So it may give it a little bit more, still not see the problem being solved, still have close to the same NOx at the outlet down here as you did over at the inlet. Then it's going to say we've got a SCR quality issue, and it's going to set a code for that. So SCR inefficiency code means that for some reason we're not getting this drop in NOx across here and getting rid of basically 99% of it, because remember, we're down to 1% of what we used to have, or 1% of what we had coming out here. So we're getting rid of 99% of it starting in 2010. So that's why the NOx levels are so low on this. It's a low emissions vehicle. Now I know there's a lot to deal with people gripe about the diesel exhaust fluid being a problem. It is a little bit tough to deal with, but as mechanics, if you learn how all this works, 70% of what comes into a shop now is after treatment problems on 2010 and later trucks. So the more you learn about this and the better you are, the more stuff you're going to be able to fix and the more money you're going to make and all that. So back to this little SCR canister here. There could be a malfunction where this puts too much DEF fluid, and what the computer wants is to put the right amount of DEF fluid in here to create the right amount of ammonia, so that the ammonia is used up in the SCR doing its job and no ammonia comes out the pipe. I believe starting in 2013, if you look in the chapter and make for sure, they started making them put a NH3 sensor after the SCR before it reaches the tailpipe, so the computer can be alerted if we have ammonia coming out the tailpipe, because it might be bad, especially somebody on a motorcycle or little kids, something like that, anybody really. But if we have ammonia being generated and being pumped out the exhaust into the air, that's a bad deal. So they made them put a sensor on there to make sure that couldn't happen. Really, it wasn't happening before enough, I don't say not to worry about, but it's just an extra step just to make sure. So they started putting an NH3 or ammonia sensor past the SCR, past the last NOx sensor. And be sure you can diagnose this stuff. These NOx sensors are like $600. So if you replace one and it doesn't fix the vehicle because it had another problem, that's bad. Don't do that. Learn how to diagnose, follow the proper steps, and not do that. That gets you in trouble quick. I've seen a lot of these change that the sensor was not bad, but some people say, well, it set a NOx code, so let's put a NOx sensor. Same thing to do with O2 sensors on cars. Don't do that. Properly diagnose it and make sure that sensor is bad before you change it. I've seen it where those sensors have been changed. It's been brought to me. We checked it out, and the doser here was completely plugged up with these white crystals that the DEF fluid forms. So if you start getting a little buildup there, it can stop completely up. And if it's not flowing any DEF fluid into here because the nozzle and all that stopped up inside there, you're going to get a sensor code on the NOx sensor. That doesn't mean the NOx sensor is bad. Okay. Properly diagnose, make sure everything's working right before you go. There's tests you can run to see if the NOx sensor is bad or not. comparing this NOx sensor to the other one. There's lots of things you can do, and it's all in the diagnostic steps. So don't do that. It's this trouble code. I'm going to put this part on there. Okay. Anywhere you see diesel exhaust fluid leak, it forms a crystal buildup, and it almost looks like a little spider web. It'll look like a spider web on the concrete. There'll be a buildup. If any of these lines are leaking, you'll start getting a white crusty buildup. Like I said, this nozzle can get stopped up in here. You can get stopped up in the tank. It has a filter in the tank, in that pump assembly there on the back, or in the pickup itself. Usually it's back in the back here, but there is actually a filter because we do get some of that little white crusty buildup. And a way to clean that up is just distilled water. You can soak parts in distilled water and it will dissolve that crystal back kind of into DEF fluid kind of. So that's the best way to clean it up, is with distilled water.